Hello everyone, welcome to my channel Chemical Engineering Knowledge. This is the 11th lecture about the thermodynamics. In this lecture we will discuss about the vapor-liquid equilibrium. So suppose we have a system, suppose we have a system in which equimolar mixture of ethanol and water is present at 1 atmospheric pressure. So equimolar, we have equimolar mixture of ethanol and water at 1 atmospheric pressure. So this is our system in which equimolar ethanol and water is present. So equimolar means that the mole of ethanol in this system will be equal to the mole of water. So the mole of ethanol, suppose it is denoted by Na, and the mole of water, suppose it is denoted by Nb. So mole of ethanol will be equal to mole of water in this liquid mixture. So this is called the equimolar mixture. So suppose we have equimolar mixture of ethanol and water at 1 atmospheric pressure. So suppose there are the number of molecule of ethanol in this liquid mixture is, suppose the number of molecule of ethanol is denoted by, suppose this one, 1, 2, 3, 4, 5, 6, 7, 8. So 8 molecule of ethanol are present in, suppose there are 8 molecule of ethanol present in this mixture, and suppose there is 1, 2, 3, 4, 5, 6, 7, 8, and suppose there are 8 molecule of water present in this system. So the total molecule in the mixture is 16, and the 8 molecule are of ethanol, and the 8 molecule are of water in the system. So 50% of ethanol will be present in this mixture, and 50% of water will be present in this mixture. So this is called the equimolar mixture of ethanol and water. So this is the equimolar mixture of ethanol and water. Now suppose we put this system in the hot water. So this is the hot water. This one is the hot water in which we place our system. So something will occur. This system will absorb some heat from the hot water. So when the system absorbs heat from the water, this liquid mixture will convert it into vapor. So in the vapor there will be vapor of water and vapor of ethanol in this space. So when we heat this liquid mixture of ethanol and water, in the above space, the mixture of vapor will be obtained. In this mixture of vapor, there will be two type of component in this mixture of vapor. So the one type will be, there will be one type of molecule in this vapor mixture will be of the molecule of ethanol. So this is the ethanol molecule, this one, this 2, 3, 4. So 4 molecules are present in this vapor mixture. So 4 molecules of ethanol are present in this vapor mixture about the liquid mixture after heating this liquid mixture. So and there will be only 2 molecules of water vapor present in this vapor mixture above the liquid, above this equimolar mixture of ethanol and water at 1 atmospheric pressure. So what will be the composition? So what will be the composition of ethanol and water in this vapor mixture in this space? What will be the composition? So the composition of ethanol in this vapor mixture will be denoted by Ya. It will be denoted by Ya, this one. Composition of ethanol in this vapor mixture will be denoted by Ya, and the composition of water vapor in this vapor mixture will be denoted by Yb. So so in this case there are two type of gases or two type of vapors are present in the above in this space. So there will be two type so the total pressure in this space will be equal to the combined pressure exerted by the vapor molecule of ethanol and the vapor molecule of water vapors. So the partial pressure exerted by ethanol in this above space will be denoted by Pa. So the partial pressure of ethanol will be equal to the mole fraction of ethanol in the vapor mixture multiplied by the total pressure of the vapor mixture. So the total pressure of this vapor mixture will be denoted by P. Similarly, the partial pressure of liquid, the partial pressure of water vapor in this space will be denoted by Pb. Partial pressure of water vapor in this above space. It will be equal to the mole fraction of water vapor in this space multiplied by the total pressure of this vapor mixture. So the total pressure of the vapor mixture is P. Similarly, what will be the composition of ethanol and water in the liquid mixture? So what will be the composition of ethanol and water in this liquid mixture? So the mixture of liquid, this is the mixture of liquid in which the number of mole of ethanol is equal to the number of mole of water. So the mole fraction of ethanol in the liquid will be denoted by XA. The mole fraction of ethanol in the liquid, this one. These are the mole fraction of ethanol in the liquid water, this one. 1, 2, 3, 4, 5, 6, 7, 8. Similarly, the mole fraction of water in the liquid mixture will be this one. 1, 2, 3, 4, 5, 6, 7, 8. So the mole fraction of water will be denoted by XB. Now, what will be the total pressure of the two components in the liquid mixture? So it will be denoted by P. And this P will be nothing but it will be equal to the mole fraction of ethanol in the liquid, which is XA. This one. This is the XA, denoted X by XA, and the water molecule will be denoted by XB. So the total pressure of liquid mixture of this liquid mixture will be denoted by P, and it will be equal to the mole fraction of ethanol in the liquid mixture multiplied by the total pressure of this mixture. So the total pressure of this mixture will be denoted by P plus the mole fraction of water in this mixture multiplied by the total pressure of the mixture. So the total pressure of the liquid mixture will be denoted by P, and it will be equal to XA into P plus XB into P. Remember that the mole fraction of ethanol and water, the sum of mole fraction of ethanol and water in the liquid mixture will be equal to 1. So XA plus XB in the liquid mixture will be equal to 1. Similarly, XB will be equal to 1 minus XA. Similarly, the mole fraction of ethanol and water in the vapor mixture will be denoted by YA plus YB. YA plus YB. So YA plus YB, and this mole fraction YA plus YB, and it will be equal to 1. So the mole fraction of ethanol and water in the vapor mixture will be denoted by YA and YB respectively. So this was all about the mole fraction of ethanol in the liquid and in the liquid and vapor mixture, and we will use the Dalton law to express the mole fraction of ethanol in this space, and we will use the Raoult's law to represent the mole fraction of ethanol or water in this liquid mixture. So for the liquid we will use the Raoult's law, and for the gaseous mixture or for the vapor mixture we will use the Dalton law of partial pressure. So remember that here, if we see to this liquid mixture, this is the equimolar mixture, means that 50% of ethanol is present in this liquid and 50% of water is present in this liquid. 50% ethanol and 50% water. But if we see to this region, so there are 1, 2, 3, 4 molecules of ethanol present in the vapor, but there are only 2 molecules of water vapor present in this above space. So the mole fraction of ethanol will be not equal to the mole fraction of water vapor in the vapor mixture. So in the vapor mixture, the mole fraction of ethanol will be not equal to the mole fraction of water vapor in the vapor mixture, but the mole fraction of ethanol in this vapor mixture will be large, because there are large number of ethanol molecules in the vapor phase as compared to the water vapor present in the vapor mixture. So the mole fraction of ethanol in this phase will be high. So YA will be greater than YB in this place, but XA will be equal to XB in this. XA will be equal to XB in this liquid mixture because equimolar. So mole is nothing but mole fraction is nothing but mole divided by total mole. So mole of A divided by total mole will be equal to XA. Similarly, mole of B divided by total mole will be equal to XB. So this is the equimolar mixture composition. Thank you very much for your attention. If you are new to the channel, please like and subscribe.